Hey guys, it's Mr. Brian here. Today we will go through the SPM 2024 physics paper. I'm partnering with Edukaji to do the paper 2 with you on the structure and essay questions. Okay, without further ado, let's get started. Okay, so this is your 2 hours, 30 minutes paper for 100 marks. Let's get to question 1 straight. Scientific investigation data of relationship between velocity and time can be interpreted by plotting graphs. Diagram 1.1 and 1.2 shows two graphs of velocity against time. State the relationship. Now guys, if they give you a relationship graph, we know we cannot just say the greater, the smaller, that kind of thing, increase, decrease. No, you have to write it in a graph way. Meaning you need to know that because this graph don't touch the x and y axis, this is velocity is inversely proportional to time. Okay, this is inversely proportional. And this is not directly proportional. The second diagram, this is increased linearly. If it starts here, I will say directly proportional. If it starts from a certain y-intercept, there's a certain y-intercept, then we call it increased linearly because it's going up in a straight line. Velocity is increasing, or velocity increases linearly also can. With time. Okay, velocity is inversely proportional to time with time. It doesn't matter, but you must make sure you write this part. Okay, increasing linearly, increases linearly, doesn't matter, right? And have a habit of writing the y-axis and the x-axis. Some people will just say, teacher, can I just write this orange color part? No, I do not recommend it. You should write it in full. What is inversely proportional to what? Yeah. Part B, the diagram shows a travel information of a man from city P to Q. Identify which are scalar quantities and vector quantities. Scalar means that there is no direction. Magnitude only, like distance. Okay, time also don't have direction. But velocity got velocity, average velocity has direction. That is a vector quantity. Has direction and magnitude. Okay. And then question 2. This is force and motion 1. The diagram shows a boy sliding down a rough inclined plane. State the force that opposes the boy's direction of motion. Well, the force that opposes his motion, because this is a rough inclined plane now. Yeah, so you're gonna say friction. Yeah, or you want to say frictional force. Can also. Both are fine. Yeah, but the weight of the boy is 300. Calculate the component of weight that is parallel to the inclined plane, Wx. Okay, this guy is 300 Newton. But question 1's, what is the Wx? Okay, Wx. You can also split your force, resolve your force into something called Wy, but they're not interested in this. Okay, but guys, in this is called resolution of force, by the way. Where you are trying to split the force into two components. Okay, you are trying to split the force into their components. The components, one of the component is the one that is parallel to the plane, Wx, and one of it is like Wy, like this. What is important here is that, first of all, you must know how to move your angle. If I give you an inclined plane of 30 degrees, do you know your angle is going to be here? And even if you don't, remember that in exam, don't panic. Just use simple maths to verify this. You have a right angle triangle here. That is 30 degrees, which is 30 degrees here. Okay, or maybe I draw a smaller triangle. Same one right here. Okay, that is 30. This is 90. 180 minus the 30 minus the 90, you're going to get 60. Okay, which means the 60 is here. Okay, whether you draw a big or small triangle doesn't matter, but the 60 is going to be there, right? And normally we like to use 30 degrees instead of 60. We like to use 30 because 30 is from the question. Okay, 30 is from the question. So simple maths to find is 60 and then 90 minus 60 to get that 30. Okay, I'm going to rub all this off. I don't want to make it too messy, but use some simple maths, get used to finding the angle and putting it at a useful place like that, 30. Okay, now after you found 30, I always tell my students, cos means closer, sine means away. Okay, closer or away from the angle. So right now, we are going to do 300 go closer to 30 degrees. 300 Newton closer to 30 degrees. That's why this is called 300 cos 30. Okay, Wx is going to be called 300 go away from 30 degrees. 300 Newton is going, you see, going further and further and further and further away from 30 degrees. You want to go to Wx and you're going further and further and further away from the 30 degrees there. And this is called 300 sine 30. Okay, that is how you calculate the Wx. I know I did it quite long, but I'm just trying to explain in case anyone has forgotten this. Answer is just 150 newtons. Okay, 150 newtons. Then the boy slides down at constant velocity. State one equation that relates F to Wx. If it's at constant velocity, then they must be equal. Yeah, F must be equals to Wx. And this is called forces in equilibrium. The concept is to talk about forces that are in equilibrium. Or you can say that they have zero resultant force also can. Or resultant force is zero. Also okay. But I would prefer the first one, forces in equilibrium. Okay. And if you are wondering, teacher, why F equals to Wx, I thought if it's sliding down at a certain velocity, then the Wx must be higher than the backward force of F because it's sliding down. Remember that you do not just look at the direction of sliding, you have to look at the acceleration. Because if your acceleration is zero, yeah, if the acceleration is zero, which is what constant velocity is, same speed, zero acceleration, it means your resultant force is zero. How come? Because resultant force is equals to ma. F equals to ma. And if your a is zero, your resultant force definitely has to be zero as well. Okay, can I? Right. Question number 3. In a series of radioactive decay, radon-222 decays to polonium-218 by emitting an alpha particle. Complete the equation. Okay, so they just want to see whether or not you know what is an alpha. If you don't know what is an alpha, then you don't know what to fill into the box there. Alpha is a helium-42 nucleus. Helium-42 nucleus. You cannot just put alpha inside. You'll be marked wrong. Because why? You must make sure this is equals to 218 plus 4. 86 must be equals to 84 plus 2. Okay, and why does a decay occur? I always say decay is a natural process. Decay happens because the nucleus wants to be more stable, or because the nucleus is unstable, right? So that the nucleus becomes more stable. That is the key. Okay, or you can say because the nucleus is still unstable, that's why it decays. Yeah, so because it is still unstable, that's why it will decay to make itself more stable. Because it wants to be more stable, also can. But B, the mass defect occurred in the radioactive decay is 0.513 AMU. Calculate the mass defect in the unit of kg. Okay, the mass defect in the unit of kg would be 0.513 times, okay, let's go to, okay, sorry, the formula sheet. to find the conversion, that would be 1.66 times 10 to the power of negative 27 kg. This would be given in SPM formula sheet, don't need to worry. That is 1 AMU. And we get a 8.5158. My calculator gave me 4 decimal places exactly, and I'm not going to round off. Usually the number's very tiny, and you just write this whole thing out will do. Part 2, nuclear energy released. Okay. E equals to mc squared. Formula also given. Make sure you use kg. Guys, be aware lah, because E equals mc squared is something that they ask almost every single year, right? It's one of those things that last year asked already, this year still continue to ask, and be careful not to forget to square your 3 times 10 power 10, 3 times 10 power 8, very common careless. Okay, the C value also given, speed of light. 7.66422 times 10 power negative 11, this would be joules. Okay, you want to round off also can. 7.664. Yeah, can. And then state the physics concept involved in the production of nuclear physics from mass defect. Actually, this is out of your syllabus. There isn't a name or physics concept in your textbook, but to convert energy to mass, from mass defect, is a concept that Albert Einstein found out. Okay, he found out that mass and energy is directly proportional. Right? Mass and energy is interchangeable. Or energy is conserved. Right? So you can say in your own words, you can say mass and energy is conserved, or are conserved rather. Or you want to say they are the same, they are interchanged, also can. Or you can also say it's conservation of energy. Yeah. So anything that just says mass and energy is conserved, is interchanged, or is equal, equivalence, you can say equal. You can even say they are directly proportional, they should accept also. That is talking about how E and M, they are directly proportional, but the C squared is just a constant, right? So just write something. If I know sometimes it's a bit K-bar like this, you never see this before, but you try to write something and just, they should be quite lenient for this kind of answers, okay? They will accept quite a lot of answers. Okay, diagram 3 shows a hydrometer with a mass of 0.028 floating in a salt solution. Okay, that's the mass. What is the use of a hydrometer? To measure density, I hope you know this. Okay, you can stop here. You want to say density of liquid, also can. But this is optional, this part. But B, the density of salt solution is 1020. Calculate the weight of the hydrometer. Okay, the mass of the hydrometer they gave 0.028. I put down here first, mass is 0.028 kg. Weight is what? Just mg, right? Guys, this is free mark, eh? Yeah, this is very easy. Just 0.028 times 9.81. Okay, I'm gonna write the whole thing. Yeah, you want to round off also can, but I think don't need to round off lah, just a few more decimals. Then state the buoyant force that acts on the hydrometer. This hydrometer is not going to fly up and it's not going to sink down, which means the forces must be in equilibrium. The weight of the hydrometer must be equals to the buoyant force that is holding this hydrometer up. They have to be equal. Okay, I'm talking about weight of hydrometer because it is floating, never move, no resultant force is 0, it is still the same. Then determine the volume of the salt solution displaced. If you are fast, you will tell me, teacher, I know this is talking about the buoyant force formula, FB equals to rho Vg or V rho G, up to you. The buoyant force is this. Density of liquid is 1020. That's from the question. I want to find volume displaced. G value is 9.81. So make sure everything is SI unit. Newton, kg per meter cube. 9.81 is meter per second squared. And so your final answer later will be in SI unit also. Okay. Now the thing is, a lot of the time, buoyant force formula is not given. Yeah, this is in meter cube. Buoyant force formula is not given. But how to write out the formula in the case where we forget the formula? Remember, Archimedes says what? Buoyant force is equals to the weight of liquid displaced. I hope you remember that. And what is weight? Mass of liquid displaced times G. Right? And then what is mass? That is the reason why, guys, in your pressure chapter, they give you the density formula. They never give you buoyant force, but they give you density formula because mass is the same as density multiplied by volume. Okay, so mass of liquid displaced, this mass of liquid displaced is equals to density of liquid times volume of liquid displaced. That is how I get the formula. Okay, but be careful, this is for the liquid. This is for the liquid displaced. Because remember, we started with weight of liquid displaced, mass of liquid displaced. Now, density and volume of liquid displaced is all about the liquid, not the volume of the hydrometer, not the density of the hydrometer. Be careful, huh? Okay, so that's how you do it. Then part C, a salt solution is replaced by glycerin with a density of 1260. Now the density increased already from 1020 become 1260. What happens to the depth of the submerged part of the hydrometer? It actually decreases. But I realize a lot of people maybe can, I don't know lah, maybe some people tembak, but part 2, a lot of people cannot get it right. Okay, it decreases. The reason, or maybe you want to ask yourself a simple question first. Do you think if I change the density of the liquid, will the buoyant force on the hydrometer change or not? Okay, ask yourself that. If your answer is yes, buoyant force changes, that means your concept is wrong. Okay, if your answer is no, buoyant force is unchanged, that means you got the right concept. Now we are taking a look again at the formula. Buoyant force is equals to rho times V times G. What changed here? Buoyant force, unchanged. Of course, G never changes a lot, right? And what happens when you change the density, when you use a greater density? For the buoyant force to stay unchanged, greater density means I need to balance, like one increase, the volume have to decrease. The volume displaced, the volume that is submerged, displaced and submerged, same, must decrease. That's why the answer is decrease. Or if you want to, you can also rearrange. Density is at the bottom. Density increase, volume displaced will decrease. One top, one bottom like this means increase, decrease. Buoyant FB never change, G also never change. Okay. Now, you might be wondering, teacher, I don't get it. Why is buoyant force unchanged? Right? Why is buoyant force unchanged? You change the density, the buoyant force will change what? No, not necessarily. Why? Because the weight of the hydrometer is this 0.275. The weight is 0.275. You go and use a different liquid, will the weight of the hydrometer change or not? No, weight of hydrometer is still 0.275. You can change to become any liquid. The buoyant force must be equals to the weight of the hydrometer. As long as it is floating, FB shouldn't change. Right? Because we talk about this whole thing about the forces are in equilibrium and all this stuff. If your weight of hydrometer never change, buoyant force shouldn't change. You get what I mean? FB won't change. Yeah, FB will not change. So changing the density, don't always think that you change something, then everything will change lah, right? So this is slightly K-bar. This is a K-bar version. Okay, because the hydrometer never change weight, right? But you might be wondering, teacher, what about those questions where I got different weight of ship? Okay, let's say this one is 100 Newton. Let's say this one is 500 Newton, but it's the same density water. So will I still say buoyant force is the same or what? Let's take a look because this is a different question from whatever in this part C is talking about. Now we are saying your weight is different. Just now hydrometer weight is the same. Because your weight is different, you displace different volumes of liquid. So ask yourself, in this formula, what do you think has changed? The volume submerged changed, the buoyant force changed, the density remains constant, the G value remains constant. I need more buoyant force, that's why I submerge lower. That is this concept. Density change or not? Never change. Then what is the previous question concept? I change the density. Do you see the difference? One is that I change the density. One is that I change the buoyant force. Because if I hold 100 Newton, I need a buoyant force of 100 Newton or else the ship will sink. If I am 500 Newton, I need a buoyant force of 500 Newton or else the ship will sink. And how do I have more buoyant force? I need to submerge more volume. The density of liquid never change. It's the same. Okay, these two are different, very different concepts. Okay, these two are very different concepts. Okay, so explain your answer. You tell them, first point, buoyant force is unchanged. Yeah, I am explaining using this formula. Buoyant force is the same, unchanged also can, is constant, and as the density of liquid increases, the volume of liquid displaced decreases. Okay, that's why the submerged part is less. So what are the keywords? Buoyant force unchanged, density increase, and liquid volume of liquid displaced increase. Sorry, decrease. 1, 2, 3. You talk about 2 out of the 3 things, you get your full marks. Okay, any 2 out of the 3, you get full marks. Can So is it difficult? Now that you know I can just depend on the formula, then it's not difficult. But you must know the formula, right? And then if question asks you, what is the principle? You say Archimedes principle. Okay, Archimedes principle. Question 5. Diagram 4.1 and 4.2 shows 2 identical wheeled bar magnets. Both bar magnets are released from position R and moving along runways with different inclinations. Okay, so one is different incliner, one is higher and one is lower. As the bar magnet enters the solenoid, the pointers of milliammeter deflects, as shown in diagram 4.3. State the physics concept that caused the milliammeter pointer to deflect. Be really careful. Concept, not law, concept. Usually, if it's a law, my answer would be Lenz's law. Why? Because this is a solenoid. Solenoid is always Lenz's law. However, because they say concepts, then I have to say electromagnetic induction. Because why? This is inducing a current, okay, inducing a current to produce a magnetic field, right? You're creating a current. The solenoid got no current one, but suddenly when the bar magnet goes in, it suddenly has a small current, right? And then they asked to compare the height released, the speed, and also the induced current produced. Okay. The height in diagram 4.2 is greater height here. Greater speed also lah, because you let it slide down from higher, the speed also higher in 4.2, and then the reading here also higher, 4.2. So 4.2 is all higher, 4.1 is all lower. Okay. Diagram 4.1 is lower than diagram 4.2. You want 4.2 higher also, okay? Huh? The speed of the bar magnet. Because you slide higher, diagram 4.2 is higher or 4.1 is lower also. Okay, you all can write like this in SPM, no problem. And the induced current produced. Just read the ammeter reading. Okay, you terbalik also, okay. 4.2 higher than 4.1. Yeah, current 4.2 higher. Okay. And so deduce the relationship between the height of bar magnet release and the speed of the bar magnet. The greater the height, then the speed also greater, right? Or you can say increase. Simple relationship. The greater the height of the bar magnet, the greater the speed. Of the bar magnet. And the greater the speed of the bar magnet, then you get more current. Of the bar magnet, the greater the induced current. Okay. When the bar magnet enters the solenoid, the bar magnet would experience a repulsive force from the solenoid. Explain how this repulsive force is produced. So now as the bar magnet enters the solenoid, it produces a repulsive force. Explain why you have a repulsive force or how the repulsive force is created. The keyword is actually induced current. Lenz's law mentioned that an induced current is going to be produced the moment there is a change of magnetic flux near your solenoid. So when the bar magnet goes close, I'm going to create an induced current so that I make myself a north or a south here to produce this repulsive force. Because when magnet goes closer, the solenoid will try to oppose the motion, oppose the change of magnetic flux that causes it. Yeah, which is a way of saying I'm going to make myself north or south to try to repel you away. All right. So keyword here is induced current is produced in the solenoid. Okay. To repel, let's say, the bar magnet. Yeah, but actually they see the word induced current, they would already accept it, lah, right? Or another way that you can say is because some people will also mention, or because they know that when you talk about Lenz's law and when you're dealing with solenoid, you will usually talk about or find about the poles of the solenoid and all that, right? The solenoid will become north and south and all that. So you can also say the solenoid becomes the same pole as the bar magnet. Pole as in the magnetic pole, like north and north. Okay, magnetic field poles, same magnetic poles, so north and north or south and south to repel it. Can also, right? But I feel the keyword here is induced current. That is Lenz's law. Lenz's law says I'm going to produce a current in the solenoid to make myself north or south so that I oppose the change of magnetic flux that causes it. So if there is a bar magnet come down, I will try to oppose, to push it away, to repel it away. Okay. Then part E is quite a K-bar one, where they mention you have a bar magnet that moves with an acceleration of 0.5 meter per second squared. The forward thrust acting on the bar magnet is 0.3. Calculate the repulsive force. Okay, this is K-bar for sure because we don't see in this chapter suddenly got acceleration one. All right, but when got mass, when got acceleration, I would think that I feel most likely there is resultant force involved in here. Right? And you can go and find your resultant force first if you don't know where to begin. This is a good start. Okay, and understand what does it mean when you say you have found out resultant force. It means that there is a certain repulsive force, right? And then there's a certain forward thrust, and now my result, my outcome is just 0.02. So if things like that become confusing for you, you label it in the diagram even, it can help you. So you have a bar magnet. The thrust, the forward thrust, meaning it has to be pointing down. Okay, repulsive force. Repel means which direction? Pushing you this way. This is the repulsive force. Or maybe I just write in short, repel force. Okay, and then what we calculated was that, okay, the acceleration is like this, huh? And what we calculated was, we found a resultant force of 0.02. Sorry, 0.002 Newton. Okay, now what does that mean? It means that if I want to find out the repulsive force, I need to minus. So guys, you all can do it separately, or I want to show you that you can also just take the 0.3 minus the repulsive force. Okay, how you want to write this one is up to you lah, huh? But 0.3 minus the repulsive force. If you're wondering, teacher, why 0.3 minus the repulsive force? Why not the other way around? Why? Because this 0.3 is a bigger, a stronger force, while this repulsive force is weaker, is smaller. How do I know? Because the acceleration is going down. It's moving down. The resultant force is going down. For you to go down, the downward force must be big. The downward force must be stronger. Or else you cannot go down. Or else you cannot accelerate down. Okay, so it's big minus small force to get this 0.002. So I do slowly, this one like this, minus 0.3, end up we get a okay, then you just remove the negative sign. The repulsive force is positive 0.298 newtons. Okay, that's how you do it. I did it quite long, but you want to do it, how you want to write it is really up to you. As long as you multiply your MA together and you need to know, I need to take 0.3 minus the repulsive force, then okay. Okay, I'll make sure you have your unit as well. And you will notice, guys, that my repulsive force is pretty similar to my forward thrust. It's going down 0.3 and it's repelled by the solenoid with a very strong force of also near to 0.3. Meaning what? Meaning I can use this concept of Lenz's law to stop a roller coaster. You know, when we are riding a roller coaster and it's very fast and I'm trying to stop a roller coaster, or I'm trying to stop a train also can. I can use this idea of having a very strong magnet and a very strong uh, conductor to try to stop, to try to produce a repulsive force to stop the fast-moving train, fast-moving roller coaster to eventually slow it down, right? So it's a pretty cool concept that roller coasters, a lot of trains use, even MRTs. Yeah, we would use this concept, Lenz's law, to try to stop a train, to produce a braking repulsive force to stop. Yeah. Okay. Question 6. Two identical dented ping pong balls are immersed into the water at 45 degrees Celsius and 90 degrees Celsius. The two diagrams shows the shape of the ping pong ball soaked for a few minutes. State one physical quantity that caused the shape to change after being soaked. Okay. What makes the ball change shape? Temperature. That is the best answer. Right? Some people may argue and say, teacher, what about the pressure and all that? I feel the best answer is going to be temperature. Different temperature cause, or you can say heat also. I don't think it's pressure. I don't think pressure is a good answer. Why? Because the pressure on both sides is actually pretty similar. On the outside, you have the atmospheric pressure, right? Here, you also have the atmospheric pressure. And when temperature increase, the ball go back to the original shape like this. And so the pressure should be still quite similar on both sides. Yeah, if outside PATM, inside also similar pressure. Inside the ping pong ball also similar pressure. So I don't think so pressure is the best answer here. Best is going to be temperature. Okay. Why does the volume of dented ping pong ball increase when soaked in hot water? Okay. Got a lot of answers. This 1 mark question, I can make it 3 mark, I can make it 4 mark also can, right? But temperature increase, kinetic energy of molecules always increase. These two always goes together one. Talk about that, you already get your mark. Or other than kinetic energy increase, you can also say velocity increase. Okay, so kinetic energy increase, velocity increase, the molecules is moving faster, which means it is going to collide more, rate of collision increase. Okay, rate of collision between molecules and the walls increase, the ping pong ball will increase. So you collide more often. That is why the volume change. Okay, so got a lot of answers. Kinetic energy of gas molecules increases. Okay, you already get mark. Okay, you can also, you don't have to just stop at one answer. I know it's just 1 mark, but in exam, in SPM, you can write more. Velocity or speed of molecules increase. Can. Rate of collision. We are not interested in collision between molecules and molecules. We're interested in rate of collision between molecules and the ping pong ball wall. Okay, that's why volume end up will increase. So you can talk about either one. Okay, but see, compare the temperature of water, 45 and 90. Okay. Diagram 5.1 is smaller than diagram 5.2. And then compare the volumes of the ping pong ball after being soaked for a few minutes. Okay. Diagram 5.1 is smaller volume than 5.2. Yeah, 5.2 look bigger. State the physical quantity that is kept constant so that the volumes of the ping pong ball can increase. Okay, physical quantity that is the same. You can say the pressure lah. Yeah, the pressure inside the ping pong ball. Okay, what if you just wrote pressure? It is all right. You can be more specific. I know the question is asking for physical quantity, but you can be specific. It is okay, right? You can also mention the mass of gas in the ping pong ball. Okay, or you just write mass, also accept mass of gas. Then based on diagram 6C, state the relationship between temperature and volume. Temperature smaller, volume also smaller, or bigger, bigger. Okay, the greater the temperature, you want to write temperature of gas also can, the greater the volume. Okay, and then state the law of physics involved in D1. This is Charles' law. This is Charles' law. Okay, like I always say, we are thinking about best thing Charles planted was green vegetables. And you don't have to write out the whole thing. In exam, you're just thinking best thing Charles planted green vegetables. Pressure unchanged. Pressure never changed. That's why it is Charles' law. Okay, temperature change, volume change. If temperature never change, then it's Boyle's law. If volume never change, then it's Gay-Lussac's law. Okay, that's how you see this. But look for the one that will never change, because two other things will change lah. Temperature will change, very obvious. Volume will change. Only pressure never change. Charles' law. Okay, the one that is unchanged is the law. The initial temperature of water in diagram 5.2 is 28 degrees Celsius. Okay, diagram 5.2, calculate the volume of the dented ping pong ball before it is immersed in the water if the actual volume of the ping pong ball is 33.5 cm cube. So this can be pretty confusing because you have the 45 degrees Celsius, you have the 90 degrees Celsius. Suddenly they say initial temperature of this is 28 degrees Celsius. Yeah, 28 degrees Celsius. So you focus only on diagram 5.2. From 28 degrees Celsius becomes 90. Okay, and then they say, calculate the volume of the dented ball before it is immersed in water if the actual volume of the ping pong ball is 33.5. This is the actual one. Yeah, this is the 33.5 cm cube. Be careful. So you actually have the volume, but you want the volume of the dented one at first. So we can call this T1, this one T2, this. Okay, we are referring to diagram 5.2 only. So from 28 degrees Celsius become 90 degrees Celsius. The actual volume is 33.5. I want the dented volume. Ignore diagram 5.1. Okay, so this is what we are dealing with. Let me put it down here. And the formula don't need to worry because it is given. You just need to know which one to use. Volume and temperature. Okay, SPM will give lah. A lot of people got this wrong last year. And it's the same mistake over and over again. Most people did like this, and they got 0 marks. Okay, it is the same mistake year after year. The problem is, for gas law, you have to be super careful because temperature only can be in Kelvin if you want to sub into your gas law formula. Gas law must be Kelvin. Okay, volume can be anything. If one side is cm cube, the other side also cm cube, that is fine. But temperature, has to be Kelvin. So you need to know you need to plus 273 to change it to Kelvin. So here, guys, if you never plus, then straight away wrong already. Is this something difficult? No. Is this something that you get reminded a lot? I think so, yes. Right? But people still make the same mistake year after year. So it's a very common mistake, or you want to write it straight away as you don't need to show it out. You don't have to show the plus 273. You can straight away count like this. Also, no problem. Okay, and so you will get 27.778. Be careful of the unit. Just now you use cm cube, now also will be cm cube. Okay. Guys, pressure can be any unit also. So pressure you can use Pascal, kilopascal, no problem. Both sides P1 kilopascal, P2 also kilopascal. I can even use units like cmHg, right? Cm of mercury, meter of water. It doesn't matter. It can be any unit of pressure as long as P1, P2 the same. Only thing to be careful is temperature. Yeah, for gas loss. And then question 7. Diagram 6 shows a filament wire with resistivity of 5.6 times 10 to the power of -8 ohm meter in a bulb. What is the meaning of resistivity? Okay, resistivity is, usually we say, okay, this is I don't know whether it's a lucky thing or not, but resistivity was the only definition that was asked in the whole paper 2 in 2024. So some students might be quite happy about it, but a lot of students I know also were quite prepared for more definitions to be asked, but they only asked one. Yeah, so this is a measure of a conductor's ability to oppose or resist also can, the flow of electric charge. Sorry, electric current. Or just current also is fine. Okay. The measure of the measure of a conductor's ability to oppose the flow of electric current. Okay. Then but B, table 1 shows the characteristics of a filament wire used in a bulb. Okay, calculate the resistance of the wire, filament wire in SI unit. This is length, this is cross-sectional area, and then this one is resistivity. So you can find a formula for resistance. Where is that? Which is this one. Yeah, where you have resistivity, length, and area. Let's use that. The only issue here is if you take a careful look at the formula, you will notice, sorry, the units, you will notice that one is in meter, one is in cm squared, and another one is in meter. So you have a problem here. Be really careful. The resistivity, you can sub 5.6 times 10 to the power of -8. No problem. Okay, that one SI unit. The length is 0.58, also SI unit. But the area is not just 1.25 times 10 to the power of -5. I am going to do it at the side here. If you want to change cm to meter, guys, normally cm to meter, I hope you know, you will go and divide by 100, okay? So those of you who are fast, you will tell me, teacher, what if I want cm squared to meter squared? You actually just need to do the same thing. You divide by 100, but you have to square. Okay, but what if I do volume? Let's say cm cubed to meter cube. Then the same. You divide by 100, but you need to cube. So I think you get the idea. And if you really forget, another way is you can multiply by cm underneath here and meter at the top. Okay, but you need to square. Why? Because cm squared and cm squared will cancel out each other like that. And then later you will get a meter squared here. Okay, 1 meter is 100 cm, right? So when you multiply by 1 over 100 squared like this, is the same now. You're actually going to, or it's actually going to be the same thing as you divide by 100 squared. Okay, so your cross-sectional area, the fast way is you can divide by 100 squared to change to meter. And if you type that in your calculator, it is going to be 10 to the power of negative 9 now. Okay, which is what we are going to sub. You get 1 mark for changing the unit. You get 1 mark for subbing everything into the formula. And then you get 1 mark for the final answer with the correct unit, which is SI unit also. Yeah, so everything SI unit, final answer also the same, SI unit. Okay, 24.192 ohms. Okay. But see, the table shows power and resistivity values for bulb JKL. Based on the table, state suitable characteristics to produce the brightest bulb. Brightest bulb. Brightest bulb should have high power. Regardless of what kind of bulb, it should have high power. Why? Because it will then help me to produce more energy. The best answer is to produce more energy. Because what is power? Power is how much energy produced in 1 second. Amount of energy produced per second. That is power, right? Resistivity is the part that a lot of people don't really know how to put it. This is a filament bulb, right? This is a filament bulb. It needs to have high resistivity, right? And the power needs to be quite high. And so that's why the answer is going to be K. A lot of people thought it was supposed to be low resistivity. Higher actually better, right? Why? Because if the resistivity is high, then I'm going to get a high resistance. Then I can also say I will produce more light. You want to say produce more heat also can. So this is a concept that is similar to heating element also. Anytime if you want more heat, more light, resistivity needs to be high. Okay, resistivity needs to be high so that the resistance is high. Guys, high resistance is going to force the electrical energy to convert into other forms like heat and light. You want the bulb to light up? The bulb also become quite hot. That's why it's okay to also say heat. Then you need high resistivity, not too low, or else the bulb will not be too bright. Okay, that is how you produce the brightest bulb. This is K. Okay, so this one a little bit tricky because we are not selecting the highest power, right? So you have to balance lah. You have to balance. We still have to write high. You cannot write lower or in the middle. Question 8. This is your geostationary, non-geostationary one. This is a weather satellite orbiting the Earth with a linear speed v. State the type of satellite for weather satellite. You learn 2 types, geo or non-geo, right? This is non-geo stationary. Okay, those of you who are wondering, teacher, when do we say geostationary? Geostationary only have one purpose or one application, that is communication satellite. For example, when do you use it? For live TV broadcasts. That is a form of communication. Okay, an example of communication satellite that you should know about is Miasat. This is the one that Malaysia launched. So anything outside of this is all non-geostationary. For example, weather satellite, GPS, Earth imaging satellite, and any other names other than Miasat. So for example, like there's a satellite called Razak-Sat. Razak-Sat. Okay, basically anything other than Miasat, which is a communication satellite or live TV broadcast, that one is geostationary. Everything else is non-geo, right? Based on diagram 7, calculate the linear speed of the weather satellite. Okay, the formula for linear speed is V equals to square root gm over r. But some people also say, teacher, there's another formula for linear speed that is 2 pi r over t, right? Are they the same thing? I'll show you in the formula sheet. They are the same thing. When to use them is depending on what information you have. Okay, when to use them is depending on what information you have. So it is this one and also this one, okay, under gravitation. Number 10 is not, number 10 is called escape velocity. So this is not, okay, this is not. So these two, they are the same thing, okay? But if you ask me, which one is more accurate? Number 8 is more accurate. V equals to square root gm over r is a little bit more accurate. Because number 5, this formula is using the assumption where the orbit is a perfect circle, which is not. We know it's an ellipse, right? It's using 2 pi r, a perfect circle. So it is not as accurate, right? But it's also a very, very close answer. Yeah. So if you have the period or what, let's say, then you use number 5. If you have enough information to use number 8, then always I would prefer number 8. The G value is given in the formula sheet, 6.67 times 10 power negative 11. The mass of Earth was given in the formula sheet. Most of the time in most formula sheet is not given, but this one was given in the formula sheet. Mass of Earth, big letter M, is 5.97 times 10 to the power of 24 kg. So you can just use that. Given, don't worry. And the orbital radius is 4.237 times 10 to the power of 7. Okay, everything is SI unit. I don't think we need to worry. Okay, I rounded off to 3 decimal places, and this is what I got. 3065.638. Okay, round off properly. Part C suggests the characteristics of a weather satellite to accurately collect weather-related information based on the following aspects. Size of antenna must be big. A small antenna versus a big antenna, what is the difference? I can receive more signal, right? To receive, to collect also can, if you like, more signals, more waves. Also okay, yeah. Energy source, best one, solar. Solar. The sun energy also can, right? Solar is the best. The best reason you go and say is because solar is, remember this word, if they ask you why solar, you always tell them because it is renewable. It is a renewable source of energy. It is long-lasting. It can keep supplying energy continuously. It prevents the satellite from running out of power, that kind of thing. So, but I feel the most direct, best answer, renewable. And mass of satellite is small, low also can, yeah, light also can. Reason, because you don't just say small mass, then it's lighter. It's too general. You have to tell them why is a small mass better, because a smaller mass satellite, if you see, if something is smaller, it's easier for me to push it up to outer space. If something is heavy, it's harder for me to push it up, right? It needs to be at a certain speed. Let's say it needs to reach a certain speed to orbit. But for you to push something lighter, it is always easier. It requires less force, less fuel, less energy, less thrust, right? Less energy can, less force can, less thrust can, less fuel also can, needed to launch the satellite. And so end up, because it is lighter, you can also relate it using your F equals to ma. If something is lighter, then you are going to get more resultant force. Let's say you are pushing it with the same force, but because it's lighter, you have a Higher resultant force can. Higher forward acceleration also can. That is also accepted. Okay, can. And then we reach section B. Okay, so in question 9, this is waves. Yeah, this is waves, talking about interference of waves. You have two coherent sources that produce wave interference. State one example of transverse wave. Okay, water waves, light waves. Yeah, any waves other than sound are accepted. Radio wave also accepted. Microwave also accepted. Gamma ray also accepted. Any other electromagnetic wave all accepted. Okay, any waves other than sound waves. Why? Because sound waves is the only example of longitudinal wave that you need to memorize. Must know this. Sound wave is the only longitudinal one. Everything else is transverse. So water wave transverse, light wave transverse, radio wave transverse, gamma ray transverse, X-ray transverse. Electromagnetic waves also transverse. Okay, you can write electromagnetic waves also transverse. Okay, part B. Two similar boats P and Q in diagram 8.1 are at different positions on the water surface. Boat P appears to swing more strongly while boat Q is in a calm situation. Explain why the situation occurred. Okay. Why boat P swings strongly, Q is very calm. Yeah, talk about the point. What happens there? Maybe I write down some explanation here. You can say that boat P is on the antinodal line. That point is called an antinodal line. Okay, or you can say constructive interference. You write what you know. Constructive interference occurs at P. Okay, what else? P is when you have two crests overlap each other. Crest meets crest, overlaps with crest at P. Okay, and why does it shake up and down a lot? Is because P has a high amplitude, has a max, not high is not enough. You have to mention the word maximum amplitude. Both P is, or both P has a maximum amplitude. Okay, or you want to say maximum displacement. So it is at the highest point. Okay, at P, what we want to say is that you have a crest plus a crest, so you have an even taller crest. You have double the amplitude of the crest, right? So got a lot of things to say. And then for Q, both Q is on the nodal line. Okay, destructive interference occurs at Q. Crest meets trough at Q. Both Q has zero amplitude. Okay, the waves at both Q has zero amplitude. So we are saying that a crest and a trough overlap each other, and as a result gives you a destroyed wave, a destructive wave. Maybe I add here waves at both Q, because the wave has zero amplitude. The boat has zero amplitude, sounds a bit weird. The wave at P has a maximum amplitude. Okay. You can't just say high amplitude. You have to say maximum is really at the highest. So P would be right here. This is where P is. And Q will be right here. So one very high and one very calm. Okay, some of the points they might overlap each other. Like for example, maybe when they mark antinodal line and constructive interference, maybe they consider as either one. You mentioned either one, they give you mark, right? They would want to see you go and mention the maximum amplitude thing. They want you to go and explain why is one swinging strongly and one in a calm situation. Right, so the one that explains it is the maximum amplitude and the zero amplitude part. Yeah, amplitude means the height of the water. Okay, so but see, if the wavelength of propagating sea wave is 34 meters, the measurement distance from the coherent source to the boat is 50 meters. That sounds like D. From the source to the boat is called D. The wave velocity is 20 meter per second. Calculate the closest possible distance between P and Q. Okay, between P and Q. So that is your coherent source, and usually this is what you call as the distance X, right? Q is somewhere in the middle, right? Q is somewhere in the middle. X is from the antinode to the antinode. So guys, in this question, you want to first of all find out the X value first. Then only you can find out the closest possible distance between P and Q. Okay, and also be really careful because in the question they did give you a 60-meter distance between the two sources. That is actually A. Okay, that's actually A. So part 1 here, you can find this formula in the formula sheet. And if you want to, you can rearrange to multiply and divide the A come down to find out X. So when you sub in, it might be easier for you. 34 is the wavelength, D is 50, A is 60. You don't want to rearrange this again? Yeah, you can sub in and find X. Okay, and so to answer this is the X. You see how I labeled the X? So the closest possible distance, PQ, should be half of the X, right? Half of X. Okay, 14.167 meters, half of X. Then in part 2, find the frequency of the water waves, the seawater. So you got frequency and then you got V and you got lambda. This one is not too difficult also because you have another formula in the formula sheet. Speed is 20. I want to find frequency. Wavelength is 34, just like that. Yeah. So the tricky part, the slightly k-bar part, is just now this one. Okay. But if you know interference very well, you know you need to calculate the X lah. This one you have to just divide over. So F is 20 divided by 34. Everything SI unit, so frequency would be in SI unit as well, which is Hertz. Okay, which is Hertz. Okay, and then the last part, the 10 marks part. Let's take a look. The diagram shows a wave breaker embankment. Okay, we want to have a little opening, and this is the embankment. The embankment is like the wall to hold on to hold the waves, to break the waves, so that I protect the coastal areas usually, the sandy area, the coastal area usually, to prevent soil corrosion, that kind of stuff. So you got 4 different wave breaker embankments. The height confirm must be high, right? If it's not high, it's not going to be able to block the waves, must be high. Opening narrow, because a small opening means I can reduce the amount of waves that can pass through. And do you notice the wave will spread more? It'll be more curvy, more circular. I want more diffraction. I want it to spread more. I want it to be weaker or has lower energy. And how do I make sure low energy? I let the gap become small. Less wave go in, less energy. more wave go in, more energy, right? So diffraction is talking about how do you make it weaker? How do you make it lower energy? Have a smaller gap. Okay, and I want a slope wall because the slope wall can reduce, let's say the water is like this, right? A slope wall can force the depth to decrease. You see this depth is like this, but now this depth is smaller. As the wave approach the wall, it forces the depth to decrease, and therefore the speed of the wave will decrease. And also the wavelength of the wave will decrease. Guys, this is the popular concept under refraction that we learn. Okay, and must be rough surface. Rough doesn't have anything to do with friction and all that, right? Rough just means because if I have a rough surface like this, and let's say water wave hit the surface, rough surface can help me to reflect the waves in all different directions. Okay, but a smooth surface is going to make the waves hit the wall and then also reflect in a very uniform manner. You hit like this and it bounces back very hard, very strongly. So what is the difference here? The reflected waves has pretty high energy right here. Okay, and the reflected waves, because it's scattered, it's all in different directions, it usually has a lower energy for the reflected waves. I want the energy to be weakened, to be lower. So rough is better. End up, we are going to choose M. Okay, and for this one, guys, I am going to show you the answer. So we have done the discussion and I just show you like what to write. The top of the table, you all can write characteristics or anything else. It doesn't matter. You can write any words. There's no mark here. So I say high, copy back lah, height of embankment. Just say block high waves, you get mark already. Or block high amplitude waves also can. Avoid water from overflowing through the wall. Because the wall is high, I don't want it to flow through the wall. Can withstand waves with a very high force, a very high energy. Okay, I want a narrow opening because like I said just now, a small opening means more obvious diffraction, more significant diffraction, wave spreads more. Energy or waves spread more also can. Then when it spread, when the wave go in and then it spread like that means what? The energy will spread out, the amplitude will also decrease, energy decrease. So a lot of things to say. And then slope shape of the embankment. This is what we mentioned just now. If I slope it, I reduce the depth, I reduce the speed, I reduce the wavelength. Water depth decreases. So speed, velocity can, speed also can. Decrease. Wavelength also decrease. Rough surface, so that waves are reflected in different directions. I want it to be messy. I don't want it to hit and reflect nice, don't want. Then I can ensure that energy will decrease. Okay, so M is chosen. Why? Because it has all these things. You copy back again. Okay, so that is question number 9, the wave questions. Then question number 10, diagram 9.1 shows a cathode ray tube. This is electronics chapter. Electrons are released from a cathode through the process of thermionic emission and then accelerated towards the anode. So you emit the electrons. Sorry, you hit, the tungsten filament is going to hit the cathode. So the electrons are here actually. They'll stand by here. And then the anode is going to pull the electrons over. Okay, accelerate to the anode. State 1 function of the milliammeter. Don't get confused by the word milli in front. Ammeter is always just to do one job, to measure current. You want to write electric current also can. Okay, ammeter is always to measure current. Then, given the EHT power supply in the diagram is 6,000 volts, the mass of an electron is 9.11 times 10 power negative 31, and the charge of one electron is this, 1.6 times 10 power negative 19 coulombs. Calculate the kinetic energy of one electron. I have right now the V, the M, the E. I want the kinetic energy, which by right supposed to be half mv squared. The problem right now, I have the voltage, I do not have the velocity, I don't have the speed. Okay, but remember guys, that your energy is also called EV. So you, in case forgotten, you go to the formula sheet and always remember, you can use either formulas one. Okay, you can use the electrical potential energy, you can also use the kinetic energy. These two, they are counting the same thing. Because electrical potential energy will convert to become kinetic energy of the electrons. How much voltage you supply later will become the kinetic energy to pull the electrons over to create the cathode ray. So whatever info you have, you use either one. Okay, right now we got small e times V, and so we're going to find out the energy using this formula, kinetic energy, but I use electrical potential energy to find. Okay, yeah? I get 9.6 times 10 to the power of negative 16. This is going to be joules. This is for one electron only. Then the maximum velocity of that electron is going to be, again, this energy is half mv squared this time. You have the energy. You sub the mass of one electron, and you want to find out the speed. Okay, so you divide over, multiply, become divide. I'm not really interested in what the v squared is, but you want to find out can. Later, I just want the v, and this would be in meter per second. Okay, let's see what we get. This hasn't been square root yet. This is I'm not interested in this. Can you all just type answer button, square root of your answer button? That would be the best. See whether you can get 4590832.71. Okay, this is from my calculator exactly. Okay, 4590832.71. You can just write it as standard form, no problem. Okay, I round off properly. 591. 10 to the power of 1, 2, 3, 4, 5, 6, 7 meter per second. Okay, that is the calculation. Then part C. The diagram shows a shadow of a Maltese cross formed on a fluorescent screen when a magnet is placed close to a Maltese cross. So in this picture, you will notice that they show a deflection of the cathode ray because there is a magnet here. That's why the shadow never forms just straight. The shadow doesn't just form here like this straight. The shadow forms slightly higher because there is a deflection due to the bar magnet present there. Okay, the question asks, explain how thermionic emission occurs at the cathode. Okay, explain how electrons, thermionic emission means what? Electrons are emitted. You want to say that I have this power supply to help me to heat up. The purpose of this power supply is to produce the thermionic emission, is to heat this, normally a tungsten filament, so that electrons gain heat energy and is emitted. And that process is called thermionic emission. So you can say something like the cathode is heated, electrons gain energy, and is emitted. Okay, just like that. The electrons gain energy and is emitted. You want to later say electrons will gain high kinetic energy later, can. Okay, but that actually happens afterwards lah. because the anode is going to pull electrons from the cathode there. But at first, you heat it up, and then it gains energy, and then it is emitted. Can already, actually. You're going to get full marks already, just 2 marks. Okay, just 2 marks. And then after that, it gains kinetic energy, then it's going to move to the anode. Then they ask you how the shadow of the multi-cross tube can be deflected. Why does it go up? Okay, I hope you all understand that this is talking about Fleming's left-hand rule. This is something you all learn in chapter 4.1. Yeah, the cathode ray, right, acts as a current flow, When electrons move one direction, it means that current is flowing the opposite direction. That one you need to know, right? So when there is a current flow and there is a magnetic field, it means that you are having a interaction. You're going to produce a force. So there's a magnet. There's cathode ray. That means there's current also. Right? Cathode ray means got current. Cathode ray move in one direction. Electron move in one direction. Current move the opposite direction always. So basically, you want to say that these two things combined together will produce a force to deflect the cathode ray upwards, to move the cathode ray upwards. Okay, so you can say something like, this is due to the interaction between the magnetic field and cathode ray to produce a force. Okay, you are likely to get 2 marks from here already straight away. Deflection of cathode ray or direction of force is determined using Fleming's left-hand rule. Okay? Therefore, the cathode ray is deflected. Okay, you don't want to say cathode ray, you can say electrons. Also can. So this is talking about the interaction that happens between the magnet and also the current. Normally we call it a current carrying conductor, but right now it's just a cathode ray to produce a force, right? And then to determine this force, we use Fleming's left-hand rule. You can always throw this in if you know. And then it ends up gets deflected. What is deflected? You say the cathode ray is deflected. You can also mention like a catapult field is produced. To produce a force to deflect cathode ray, that kind of thing. Right? All this is under the same concept, but it's only 2 marks lah. So you can write anything you know, and if your points touch on any of the points, then you're gonna get full marks. Yeah, catapult field also can. Okay, but the first sentence itself can give you 2 marks already. Interaction, and also that produces a force. That's why you get a deflection. Okay, and then you can throw in Fleming's left-hand rule. Throw in catapult field if you know. Okay. Part D, the cathode ray tube is used in a heart rate monitor machine. Table 4 shows the specification of 4 cathode ray tube PQRS. So down here they also mentioned you want to determine the most suitable cathode ray tube to be used in a heart rate monitor machine to produce a clear and accurate signal display. Explain the suitability of each specification and determine the most suitable one. Okay, so we take a look at power supply X first now. Between 1.5 volt and 6 volts, I would want 6 volts. I would want the higher voltage, right? Why? Because I would then produce more heat and am able to have more electrons emitted, more thermionic emission occur. Okay, and then you can also say for power supply Y, got 4 kilovolts, 5 kilovolts, and 6 kilovolts. I want a high value. Okay, 4, 5, 6, all also quite high. Yeah, not bad. And then I want a vacuum, I don't want air. I want vacuum, I don't want air. Lastly, I want deflection plate. Okay, so it looks like end up we are choosing Q as the answer. Yeah, notice they like to play with the numbers. It doesn't have to have a highest power supply Y. This kind of essay you have to balance. You got 4 characteristics. You must balance all 4. Make sure that it is the most suitable one among the 4. So you don't say I want 6 volt, I want 5 kilovolt. You just say high can already. Okay, so I already typed the answers. I just go through like what we mentioned earlier. High supply X, power supply X. Understand the X is to do what? The X is just to heat up. So you can say produce more heat. Produce more thermionic emission. Higher rate, okay. More also okay. Okay. More electrons will be emitted. Then Y is to do what? Y is to pull the electrons over to generate the electrical potential energy to attract the electrons over to the anode, to increase the speed, the velocity of the electrons or cathode ray, to produce a high acceleration for the electrons, to produce high electrical potential energy, to uh, produce high kinetic energy of electrons also can, right? So that it moves faster. You want to pull it over from the negative cathode to the positive anode. Pull it over. I need a deflection plate because your heart rate monitor need to sometimes go up, go down, go up, go down. So I need the cathode ray to go up, come down, go up, come down, go up, come down. And that only works if you have a deflection plate to deflect the electrons or cathode ray. Okay, why we choose vacuum, not air? Because vacuum means that it will not collide with any air particles. The electrons will just move. Remember, air is very heavy. Electron is just a subatomic particle, right? So if you have air particles, it will be blocked. The electrons will be blocked by those air particles. So I don't want it to collide with any air particles so it can move with maximum velocity. Okay, so that there's no energy loss for the electrons. It will not hit anything. No obstacles for the electrons also can. Yeah, end up Q is chosen. Then you repeat now. It has high power supply X, high power supply Y, has a deflection plate, and vacuum in the cathode ray tube. Okay, can. So a lot of people preferred the wave question, but the wave question also has certain like tiny traps lah, I would say. Yeah. Especially the calculation bit a bit, and then the how to explain why the both P and Q is different and all that. Yeah. Okay. Then lastly is light in section C, which is your compulsory section. Diagram 11, or sorry, 10.1 and 10.2 shows light ray with an incident angle of 60 propagating from air to block S and block T. State the phenomenon of light that occurs. Refraction. Right, because you go to a different medium. Refraction of light. Okay, you just say refraction can already, of light is optional. Compare the angle of refraction, optical density, and velocity of light passing through the block in based on diagram 10.1, 10.2. Guys, essay question must write properly. So you have to say angle of refraction in okay, let's take a look. Angle of refraction is bigger for the first diagram, yeah, compared to the second diagram. Greater than. Number 2, optical density. Guys, what if you never mention diagram 10.1, 10.2? Instead, optical density you say for block T and S, also accepted. Okay, you don't have to say diagram 10.1, 10.2. You can also say block T and S if you prefer. Okay, right now the refractive index is 1.52 and 2.42. So one diagram 10.1 is smaller than 10.2. Lastly, velocity of light passing through the block. In diagram 10.1. Okay, so they didn't tell you about the speed or the velocity, but you have to be able to figure out yourself. 10 diagram 10.1 has a lower refractive index. This one higher. It means that diagram 10.1 has a lower optical density also. Oh, sorry, I just now when we answer part B2, I didn't realize that they were asking optical density. I thought they were just asking refractive index. But a low refractive index means a low optical density, right? So okay, just nice. And then low optical density always means that it is going to move faster. Okay, faster as compared to this diagram. And faster means you will see that it will go away from the normal. Okay, away from the normal meaning it should have a bigger angle. Bigger refracted angle. Okay, that's why if I'm comparing between R1 and R2, how do I know who is faster? This definitely has to be faster because this is further away from the normal. This has to be slower because it is closer to the normal. And also, you can compare the refractive index to know the density. Lower density means that it has to travel faster. Yeah, so diagram 10.1 is greater than 10.2. Okay. And then deduce the relationship between refractive index and optical density. It looks like greater refractive index, greater optical density. This is what we just mentioned. Or higher also can. Up to you. Greater, higher. Or increase. The higher the refractive index. My bad. The higher the optical density. Okay, refractive index and velocity of light. It looks like if it's higher index, denser, then it would be slower, lower velocity. The lower the velocity of light, passing through the medium. Okay. So just write properly for this one. And then part D, diagram 10.3 shows a coin in a glass filled with water. Explain why the observer sees the position of the coin closer to the surface of the water. Okay. The one that we see is known as the apparent image. That's why this is called the apparent depth. This guy is apparent image. That's what your eyes will see, which is slightly higher. Okay, so what to talk about? They are quite nice because they already put an arrow for you to remind you light is traveling from water to your eyes. From water go to air. Okay, from water go to air. So you want to talk about how light is traveling, number one, from water to air, which is a denser to less dense medium. high to low density medium, which is why it will explain refract away or towards the normal, right? If you go from to a less dense medium, it will refract away from the normal. And then you can talk about the speed, because refraction always is related to change in speed and all that. All right, so you can say lah, light propagates from water to air. Okay, light propagates from high to low optical density medium. Light refracts away from the normal. Okay, by the way, this is 2 marks. Refract 1 mark, away from the normal 1 mark. Okay, you talk about water to air, high to low dense, you get 1 mark. So you want to combine them together, but guys, you don't know which one is going to be the one that will be awarded marks. So I feel you should write down everything you know, right? You can write more if you have time. Huh? And how do I know it refracts away from the normal? Well, you can see that the wave at first, oops, sorry, wrong one. The light at first is like this, and then now it goes away from the normal. It bends away from the normal a bit. Okay, it bends away from the normal to go into your eyes, which makes sense because you go to a low dense, high to low dense medium. When you go to less dense medium, it would be faster. And faster, I always tell my student means away from the normal. Okay, why? Because I always say you think about FAST. Faster means it will go away from normal. And if it's slower, it will go towards the normal. Okay, so if it's slower, it will go towards the normal. Then you can also say lah, velocity or speed of light velocity or speed of light increases. It becomes faster when it enters air. Okay, you can also say about, so we talk about, this one is extra lah, but we talked about high to low dense and all that. You can also say refractive index of water is higher than air. Okay, you can use this symbol, no problem. And then you can say observer sees the apparent image. Okay, coin is seen at the apparent depth. So really got a lot of things to say, huh? Right? So what are the keywords? Optical density, talk about that. Or water to air. Speed or velocity. You can say in air is faster, in water is slower. You can play around with your words, it doesn't matter. You can talk about refractive index. You can talk about apparent image. You can talk about apparent depth. A lot of possible answers. Quite easy to get full 4 marks, actually. Right? You say refract away from normal, you already get 2 marks out of 4. Right? So anyone that I underline, those are the key points. Yeah, in this SPM question. Okay, part E. Diagram 10.4 shows a piece of plastic optical fiber used in endoscope to see internal parts of a human body. The endoscope is equipped with a camera that allows doctor to see the images taken by camera on the screen. You are required to make recommendations to improve the efficiency of the optical fiber to produce a clearer image based on the aspects on flexibility, refractive index of inner core and outer cladding, purity of inner core material, suggests whether you want a single or bundle form. Okay, so I want high flexibility for sure, can bend easily around corners, right? I need it to bend because endoscope, you need it to put into a human body, usually through the throat, right? Or sometimes through the bottom of your digestive system, yeah? So usually through your throat, lah. And you need it to bend. You cannot have a very stiff fiber. It needs to bend through your esophagus and bend through your intestine sometimes even. Refractive index, this one got a few ways of answering it, lah, but I feel the better way is you must mention that the core must be denser, okay? Outer cladding must be less dense, or else total internal reflection cannot work. Or it also means inner core must have high refractive index, outer cladding must have low, or else total internal reflection cannot work. Because for total internal reflection to keep on occurring at all these points, it must happen inside a dense medium, trying to go to a less dense medium, or else cannot. Okay, just like how total internal reflection occurs in a diamond. Let's say this is a diamond. How come can keep on occurring in the diamond? Yeah, it's because it happens in the denser medium. Outside is less dense. Diamond is very dense. It happens inside. Internal reflection means inside the dense medium. And also the incident angle must be bigger than the critical angle. Okay, so it must be high dense to low dense, denser to less dense, must be incident greater than critical. Then only it can happen. Purity must be very high so that you won't have any signal loss. Meaning of signal loss means, let's say this part is not very pure. There is a chance where the light signal might possibly escape out, refract out, because the optical fiber is actually just a transparent, it's like a glass noodle like that, usually, right? It's a very thin, transparent glass or plastic usually, that looks like a glass noodle, transparent, and light gets stuck inside. But if that part is not very pure, right? Maybe that part cannot have total internal reflection occur, and what might happen is the light might just come out, might refract out instead of keep on getting stuck inside. We want it to be inside. We don't want it to come out. Okay, so purity must be high. And the inner core material, you have quite a lot to say lah. You can say, I want it to be high dense, high refractive index, that kind of stuff. And then I want a bundle. We don't just put one fiber normally. Normally you have a bundle of fiber go in. Okay, so it's a very thin fibers and you want a few of them bundled together. Normally for endoscope, extra info, you will have a bundle that will help to send the light down because inside the digestive system, you cannot really see. So we need light to be sent down through one bundle. And then I need another bundle to help me to capture the image to bring the light signal out. Okay, so the image is captured by every single fiber will capture like a tiny pixel. Okay, a tiny pixel to create an image of what is happening inside. And somehow you put a tiny camera inside to capture all that light and send to the computer so that you can see it on the screen. Okay, so I give you some answers here. First one is talking about flexibility. I would just say high reason to bend easily. You can say around the corners and all, because you have so many corners around your in your body, in your digestive system especially. And then this one, right, I didn't split it up, but you want to split also can. I go and mention refractive index of inner core higher than outer cladding. Because if it's not higher, if it's not denser to less dense, total internal reflection won't be able to happen. So I say so that total internal reflection can occur in the inner core. Purity high, reduce signal loss, light loss, data loss. I don't want the light to come out like this. I want all of them to undergo total internal reflection, not refract out. Okay, light is not blocked or absorbed. Very pure means Imagine if inside got something not very pure, meaning got like some impurities, it might be there to block the light, right? It might be not fully transparent and that part will block some of the light. So blocked or absorbed by some impurities. Okay, inner core, I want a high refractive index, high optical density. Because high refractive index means smaller critical angle, more total internal reflection can occur, yeah, higher refractive index. So similar one, these two, small critical angle, total internal reflection can occur. By the way, bigger N means smaller C. Smaller C value is easier. Smaller critical angle is easier for total internal reflection to occur. Later I explain. And then you can also say, I want a glass, a pure glass, pure glass, strong glass also can, or fiber plastic for the inner core, because it has high purity, so that more total internal reflection can occur, can transmit more light, more signals. And I want a bundle, a bundle of optical fiber, because why? More signal or data can be transmitted, reflected at one time. This one is bundled. Yeah. A lot of it, that means can transfer a lot of signal at one time. If it's one fiber, only a single fiber, one fiber, you only can transfer one light at one time, right? One signal at one time. Okay. Uh, just a quick one for this one. Why smaller critical angle means more total internal reflection? Because let's say I have two different, maybe I draw it down here. Let's say I got two different glass blocks, two different materials. Now these two materials, wait, okay, wait, this is a bit laggy. Okay. Okay, these two materials, they are different and therefore they would have a different index. They would also have a different critical angle. So let's say this one, it has a critical angle of 40 degrees, while this block here has a critical angle of 60 degrees. Now, if I have a incident angle that is exactly the same for both, okay, both also 45 degrees. Yeah, both also 45 degrees. This is the incident angle. You will notice a small critical angle will ensure that my I is easily bigger than the C. It's very easy for my incident angle to be bigger, which is a requirement for total internal reflection to occur. If you are going from denser to less dense, yeah, the block is denser, the air is less dense, and also if your I bigger than C, what will happen? Total internal reflection occurs. Smaller critical angle allows total internal reflection to occur. But what happens here? Incident angle is smaller than critical angle. The 45 smaller than 60. So what happens? No total internal reflection. I write short form, which means it is going to refract out and away from the normal. And see, so a smaller critical angle is good. It's easier for the light to achieve that smaller critical angle because your incident needs to be bigger than the C. And then if your C is very small, then it's easy for me to be bigger than the critical, right? If your critical angle is a bit too big, then a lot of the light cannot be bigger than it, cannot be bigger than this very high value, 60 degrees, let's say. And so a lot of it will just come out, refract out, right? Which is why you're going to get signal lost. Yeah, so we want small critical angle. Okay, that is the reason why I write small critical angle as my reasons also. So any 5 lah, then you can get full marks already. Okay, and you must mention the bundle one because they asked to specifically mention the bundle one. Okay, so the bundle one is going to be 1 mark. Just transmit more signal. And that is the end of your SPM 2024 physics paper. Right? Overall, it's quite a good and balanced paper. It really tests, got some easy questions, definitely, but also got some questions that requires you to think a little bit. And if you are answering the wrong concept, then it might be difficult for you to hit that A and A plus, Yeah. So good luck to those of you sitting for SPM. That is it for SPM 2024. Wish you all the best. Yeah.